Welcome to Click for IB Biology. We're studying climate change, and in this particular video we're going to be looking at the phenomena of upsloping or upslope shifting. There's a PDF of this presentation that you can download from the description below the video. You can annotate that with your own notes, and then at the end, why not take the 10-question quiz, check the answers, which are also provided, to evaluate your understanding of this particular part of the course. So global warming is responsible not just for poleward movements and redistribution of species, but this phenomena also exists with respect to altitude. So we know that altitude is responsible for successional changes, and therefore if we change the temperature, then we change the various niches which are available at different altitudes, and this results through the competitive exclusion principle in species redistributing themselves and indeed possibly leading to the extinction of certain species in particular areas. In the 1960s, there was a famous study by Jared Diamond, a well-known author of biology books, in Papua New Guinea on a mountain, that should be Mt Kirimuri, which has an altitude of 2,520 meters. And Diamond, progressing up the mountain regions, he plotted the distribution of the various species of these tropical birds in that area. In the in 2014, Ben Freeman and his wife Alexandra, they resurveyed the bird distribution and discovered that there had been what is known as an upsloping shift, which is to say there is an altitude zonation change due to what they believe was global warming. In this study, the bird which is shown in the image here, which is a white-winged robin, that its distribution limits had changed from an upper limitation of 2,130 meters, had gone at least 100 meters higher in its distribution in the time frame between when Diamond and the Freemans carried out their study. This altitude increase is causated with the average increased temperature of 0.39 degrees centigrade per year. And so what's happened is that the increase in the temperature has modified the habitat at this altitude such that the white-winged robin is able to extend its niche occupation to a higher altitude, and possibly coming under stress at lower altitudes as they have become too warm. So this is a phenomena called upsloping shift. Equally interesting is that the height of the mountain is limited to 2,520 meters, and it's thought that for a 1 degree extra 1 degree shift in temperature, this would further push the white-winged robin right to the summit areas of Mt Kirimuri from their previous lower levels some distance below. But the process of doing so would bring the white-winged robin into conflict with the mountain gerygone, the crested satinbird, and the berrypecker, and the consequence of which is that this habitat niche interaction would result in the exclusion of these species for a number of reasons. Firstly, because it would come into conflict and competition with the white-winged robin, but which would be better suited to that particular modified habitat, but that the modified habitat physiologically would place too much stress on these higher altitude birds, and that they would be excluded from reproducing successfully in that region. So all of these are phenomena of upslope shifting, as we see in the Papua New Guinean Mt Kirimuri study over the past number of decades. Let's move on in our study to the next video in D4.3 to look at the impact on the coral reef formations. There's a chance to subscribe to the channel. The playlist is there for your convenience. Thank you very much for listening.